Intelligent selective electrodialysis. For hydroponic growers around the world, starting with the US, we are developing an intelligent water treatment system that will save growers water, energy, and fertilizer. My name is Kishore Nair. I'm a PhD candidate in mechanical engineering at MIT, working at one of the world's leading clean water technology labs, and I am leading this initiative. Meet one of our potential target customers, Winsett Farms. What you see over there is 168 acres of glass and steel that's growing tomatoes and peppers. Winsett Farms it's what you call a hydroponic high-tech greenhouse. They're the future of food. There are about 50,000 acres worldwide that looks like this. And they produce about 10 times more food using 10 times less water than conventional farming. Now, here's a problem. Many of these greenhouses are in places where there's salty groundwater, and that's their main source of water. Now, on the left side, you see how a healthy lettuce looks like. And on the right side, you see how it looks like when it's damaged with salt. Now, a lot of these greenhouses, they use reverse osmosis systems to remove the salt. The salty water comes into the reverse osmosis system. It removes the salt. And here, RO is like a hammer. It removes everything in the water, including the useful calcium and magnesium. And then the growers have to pay to put back in that fertilizer. Add to the fact that RO also wastes a lot of water. Now, what is our technology? Intelligent Selective Electrodialysis, or ISET for short. We've radically redesigned an existing piece of hardware called monovalent selective electrodialysis that selectively removes monovalent ions. We've combined that with the latest state-of-the-art sensors and a proprietary software that we developed, and put it all together, and we get the system called ISET. If RO was a hammer, we are more like a scalpel, which removes just the nasty ions from water, leaving the good ions. Now, Leon wanted me to talk a little bit about the core principle, and it's a membrane-based technology. You can have groundwater coming in, and there are many membranes in parallel. The membranes are monovalent selective. So you have groundwater with all of these ions coming in, and what happens is only the sodium and the chloride is separated off. So you end up with one stream which is high nutrient water and low sodium and low chloride, which is exactly what the growers want. ISET is better than RO. We save more energy, we save on fertilizer, and we save on water. And the expected payback is about 2 years. We've received a positive market response. We've interviewed about 80 growers in the US, Mexico, and Netherlands, with site interviews in Florida, Mexico, and in California. And I'm just quoting one of the growers who, when he saw what our capabilities were, he was telling me your technology will have huge market penetration. That's Howling's Tomatoes, which is one of the biggest tomato growers in the US. And we've got about 10 growers who are interested in working with us in testing the technology out. And some of those logos are mentioned there. ISET we've costed out what is a market opportunity for this technology, this whole life of this technology. I see this technology as a replacement for reverse osmosis for the next 50 years to come. And this is how this technology, I believe, will diffuse through. We've costed out the hydroponic market. That's where we should start with. And it turns out that golf courses actually are very interested in what we do as well. And our final goal is eventually bringing down the cost so that we can serve the conventional agriculture market as well, which is a few years out because the costs need to be brought down significantly. But that's the future, to save on water and food security for the next 30, 40 years to come. Now, we also identified that the core capabilities is useful elsewhere as well. Salt production was where this technology first came about, and some of our innovations can feed back into that space as well. We've talked to some manufacturers who's interested. Lithium mining companies have also reached out to us to see if this capability could be useful to them. And we are figuring out how to chart that path as well. This is the team that's making it happen. The core team consists of me and my CTO, Ivana, and our PhD thesis advisor, Professor John Leanhut. I've got about 6 years of experience in desalination R&D. I've been working on this concept for 3 years. And I also have 4 years of part-time direct sales experience running nonprofit organizations. And Ivana's got 3 years of experience in desalination R&D. Professor John Leanhut, who's our thesis advisor, has helped start 2 desalination companies. And we have a fantastic team of business and technical consultants and advisors who are advising us and taking us forward. Not to mention the great catalysts that I have here too. They've been hugely supportive. Now, this is the paths that we see forward. With the help of JWAFs, we've come this far and taken an idea and costed the market out, evaluated the market. We are looking to run field pilots starting in September and looking to raise a seed round of funding a few months after that once we set certain, de-risk some aspects of the technology, and we've costed out how much it would take us to get to the next stage. We're looking to, for these cases, that if anybody knows of resources that can help us out on field piloting in lithium mining or agriculture, you're welcome to talk to us. We'll be at poster number 1 in the next room. Thank you.